Good morning everyone. Today we are going to do a presentation along with the activity which shows what liquid pressure is. So we have the team members here, Anjita, Navrata, Shekha, and Lavinia and myself Nitali. So we'll be starting the presentation. Now I'll be explaining what is liquid pressure. Liquid pressure is the force exerted by a liquid per unit area on the walls of its container or any object placed in it. The pressure a liquid exerts is largely influenced by the depth and density rather than the amount of liquid present in it. For example, if you dive deeper into a pool, the pressure you feel increases. This happens because there is more water above you pushing down due to gravity. In this presentation, we will explore how liquid pressure works and things regarding it. Now I want Namrata to speak more about liquid pressure. Which is open at one end and the other end is wrapped with a balloon. So the tube is held vertically and a small amount of water is going to be poured in it. The balloon is bulging. That means liquid exerts pressure. This bulging means that is liquid pressure and liquid exerts pressure. At the base, it's really broad. So this is because dams have broader bases to withstand immense pressure exerted by water they hold back. The pressure from the water increases with depth, as we discussed earlier, and the deeper the water, the greater the force exerted on the dam's structure. To ensure the dam remains stable and doesn't collapse or tip over, it must be designed to handle these forces effectively. Now, you might have all noticed that these water tanks are always on top of buildings and not on the bottom. So why? From the perspective of liquid pressure, placing the water tank on top of a building is essential because it maximizes the height of the water column, which in turn creates the necessary pressure to ensure that water flows throughout the building, even to the highest floors. This is cost-effective and efficient way to maintain adequate water pressure without needing complex pumping systems. Now I invite Navratna to tell us more. Sorry. Same thing. The other experiment we have showed that liquid exerts pressure because this balloon is bulging. But now when we increase the liquid column, we can see that this balloon is bulging even more. That is because when the height of the liquid column increases, the pressure also increases. So this is an experiment to show that. Which is an experiment to show that liquid exerts pressure on the sides. So here you can see that this water is going sideways. So that means liquid also exerts pressure sideways. Plus, you can also see that this water is going at, not at the same strength, but at different strength. So here, when it is a little bit, when the depth is a little decreased, here you can see that the water is a little going a little weakly, and here medium depth, so a little more strength. While here it is going at maximum strength because it is there is a lot of height, there is a lot of depth here. So this has more strength. So this also can prove that higher the depth, higher the pressure.
When a liquid is at rest, the pressure it exerts at a particular depth is the same in all directions, downwards, sidewards, and even upwards. This is because the molecules in the liquids are free to move and transmit force equally in every direction. At a given depth, the weight of the liquid above that point creates pressure which gets distributed equally around that point. This means that if you measure the pressure at the same depth on different sides of the container, you will find it to be equal.
In conclusion, liquid pressure is a key property of fluids that increases with depth and acts equally in all directions at the same level. It depends on the height of the liquid column, the density of the liquid and gravity. This explains why containers and structures like dams must be stronger at the bottom and why water tanks are placed at heights to create sufficient pressure. Understanding liquid pressure is essential for many real-life applications in science and engineering.